this subchapter 4.3, we are learning about IP protocol. Especially in this lecture, we learn about this IP version 4 addressing scheme. Okay, let's move to the next. Okay, here we are using IP address 32-bit identifier for host and the router interface. And this one is host interface, and this one is router interface. This one and this one. We need 4 IP addresses here, and we learn about this one. And this is called interface. And the interface means the connection between host, router, and the physical link. Routers typically have multiple interfaces, and host typically has 1 or 2 interfaces. For example, wired Ethernet and wire is 0.11 A, B, or G, or N. We need this interface, and IP address is here. Also here, we are requiring this IP address to use internet. Thus, this IP address is associated with each interface. And IP address is based on this decimal notation. Here, this one is 8-bit, and next one is also 8-bit, 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 and this one is 4 byte, 32-bit addresses here in binary format. Then how are interfaces actually connected? This topic is probably discussed in the chapter 6. Usually that interface topic is related to the physical layer, and about the Ethernet, this topic is discussed in the chapter 6. And even though that is data link layer, Ethernet is related, thus that is discussed a little bit. And wired Ethernet interface is connected by Ethernet switches. Here we are using wired LAN and wired Ethernet, and we are using this switch. This is Ethernet switch. This is router. We don't need to worry about how one interface is connected to another with no intervening router. Here, this one is wireless access point, and this one is also using this interface. This one is physically interconnected. And here, we don't need to worry about how one interface connects to another if we are using this wireless access point. This wireless Wi-Fi interface is connected by this Wi-Fi base station. Think about our home network. We are using wired Ethernet, also wireless Ethernet. And for the wireless Ethernet, Wi-Fi, we are not using any physical line. And anyhow, we'll look at this one later, a little more in detail about this. Anyhow, we are learning about the IP addressing scheme, and anyhow, we need to use that IP addresses to hook up to this internet to identify properly. And this one is explaining about the topic about subnets. What is subnet? Here, if we are considering IP address, then that IP address is composed of subnet part and host part. This is IP address, 4 byte. Then this one is MSB. This one is LSB part. Then this part is subnet part, lower part that may be used for host identification. And this one is called subnet part, and we learn about this. What is a subnet? Device interfaces with the same subnet part of IP address. Here, this one is subnet address. This one is subnet. And those are different from this. This one is other subnet. Also, this one is another subnet address. In each subnet, we need host part to identify each host. Also this one. Also here, we are using host part to identify each host in each subnet. This subnet can physically reach each other without intervening router. Think about this one is a kind of bridge. Even though we are disconnecting this one, they can be interconnected. They can be reached to each other. And if we are detaching this interface, then they are isolated islands, and each island is one subnet. Here, this network is consisting of 3 subnets, 1, 2, 3. Let's move to the next. Recipe. How to determine the subnets, detach each interface from its host or router, in this case, router. Creating islands of isolated networks. Detach this. Then each one, isolated one, that is called subnet, different subnet. We have 3 different subnets here. Each isolated network is called a subnet. We can think this one as a bridge. Even though we are not using this bridge, we can reach other node or other host because we are located in the same island. But we cannot go out to other island because that bridge is disconnected. Thus, each isolated the island can be an analogous example for subnet. Here, to differentiate among 32-bit IP addresses, we are using this slash and number. This number means how many bits are being used for that subnet. Here, 24-bit among 32-bit, this 24-bit here, that will be used to identify each subnet. And this notation, slash and number, that is CIDR format. We learn about this one later. This one is subnet mask. And in other format, among 32-bit, 24-bit is being used. In our case, normally we are using in this way: subnet mask 3 byte 255 and 0. This notation is same like this /24. Among 32-bit, this 24-bit will be used for that subnet address. This notation is different but same meaning about subnet part. Let's move to next. This slide is asking how many subnets are here. Here, the blue area, one subnet. Okay, let's move it back. Okay, I'll use this color. Okay, this one subnet. Also this one, 2 subnet. Third one. Also, this one is, even though that seems to be simple link and no other computer here, that is another subnet. Also, this one is another subnet. Oops, sorry, this one is 4 and this one is 5. This one is 6. Thus, we have 6 subnets here. Okay, let's move to the next. Okay, we can use these class type IP addresses. Here, always this one is being changed, thus I'll change it back. Okay, this one is using class A, class B, class C, class D to differentiate the different group of IP addresses. Class A is like this. Among 32-bit, this one is 32-bit, 4 byte. First byte and MSB part. This one is LSP side. MSB part, that first byte, that is being used for network identification. Next 3 bytes, among 4 bytes, that will be used for host identification. In the class B, 2 bytes are being used for network ID, and another 2 bytes are being used for host ID. Class C, in this case, first 3 bytes are being used to identify the network, and the final 1 byte will be used to identify host. And D class, that is being used for multicast groups. And class E addresses are reserved for research purpose. Thus, you don't need to worry about this. And please try to remember these 3 classes, A, B, C. Here, if we are looking at these IP addresses, then the range will be like that. Because class A is using first byte for network, this address range is like this. We are changing it to the binary format. This. Class A. Only this one will be used. And class B, to differentiate between them, this one is using this one, and another byte will be used, but first byte. This one is explaining only the first byte among these. There's still another 1 byte will be used, but this one is showing this first byte. Also, next one is, even though that is using 3 bytes for network address, network ID, first byte will be used. Thus, we are looking at that first byte. then that is like that. This range, that is called first octet. Octet means byte. If we are showing in decimal format, that range is like that. And anyhow, that will be explained in the next slide. Just let's move, and we can understand better. This one is still explain about that class IP addressing in IP version 4. Oops, always we should change it back. A class, number of networks 126, and number of hosts per network. We are using remaining 24 bits for host ID, the 2 to the power 24, that is like that, 16 million around. This one, we are using 2 bytes, that means 16 bit, that's the 2 to the power 16, that is like this. And C class, we are using number of the host ID, as host ID, we are using 3 bytes, that is, host ID just 1 byte, that is 8 bit, and that is 2 to the power 8, and this one. But actually this one is 256. The others are, the number is so huge, thus we couldn't not differentiate. But actually that is -2. Also this one is -2. Why that we are subtracting 2? Following in the following slide we can understand. To eliminate all 0, all 1. This one is to use for the network identification, and also this one is being used for broadcasting purpose. And next slide will explain about it. And you don't need to hear about this multicast T class. Multicast T class. You don't need to hear about this. Okay, in other ways, this one is explaining again IP address class A, high order bits. First bit, that is MSB, that is 0. And the first octet, first byte address range is, as we learned and we observed already in the previous slide, this is the range. And the first bit, that is being used for this class B, thus we cannot go to the 128. This one is being assigned to this class B. Class B is like that. We are only considering the first byte here. Even though we are using another byte here, another 2 bytes for this, for network address, and we don't need to talk about this. And class C is just 110. 110 means that is 128, and that is the 64, that's 192. From that, the decimal number is being started. 10 here, that position is 128 among 8 bits. So after that, we are using. And number of bits in the network address, even though that we are using just one first byte to show this address range here. In this class B, we are using another, okay, first one, second one, that's 2 bytes, that's the 16 bit. And this one, we are using 3 bytes for network ID, that's the 24 bit, that means 24 bit. Okay, you don't need to know about this. Let's move to the next. Some IP addresses are reserved for special purpose. let's look at this one. Let's change it back. Certain host addresses are reserved and cannot be assigned to devices on a network. And an IP address that has binary zeros in all host bit positions is reserved for the network address. I showed you already. If those are all zero, this host part, this is network part among 4 byte, among 32 bit. If those are all zero, then that is reserved for the network address. And okay, this one is explain about that. And all host part IP address, that is 111, 8-bit, those are being used, assigned for broadcasting address. Thus, that cannot be used to assign this ID number to host ID to computer, and that cannot be used as a host ID. That is not possible, this assigned one. Thus we are subtracting 2, this one and another one. Why we are using, in the previous case here, why we subtracted? That is the reason. We are subtracting this one, all 0, first case, and the second case, all 1, that is for broadcasting. All 0, that is for the network address. All 1, that is for broadcasting address. We are subtracting. There's 2. Okay, let's move to next. Also, we should remember private IP addresses, because we are using these private IP addresses almost every day. We are using this one in our house or campus network or company network. What is this private IP address? And this one was this slide. Some slides are from Cisco's CCNA textbook or CCNP. There is some textbook from Cisco, and there is CCNA textbook. And a few years ago, I used this CCNA textbook for our computer network lecture. And this slide is good to understand about the private IP addresses that I brought here. Okay, let's read this one first. No two machines that connect to public network can have the same IP address, because that is unique. Our IP address, that should be unique in the world. Worldwidely unique. Because public IP addresses are global and standardized, and these IP addresses are unique. However, private networks that are not connected to the internet may use any host addresses as long as each host within the private network is unique. Think about our home, and we are using many computers and notebooks here, and that IP addresses, same IP addresses, if that is private IP address, that may be used here in other home, worldwide, in many places, because that is not unique. Same one here can be used. That is called private IP address, and this one is explaining a little bit more in detail. However, private networks that are not connected to the internet may use any host addresses as long as each host within the private network is unique. And this RFC, this 1918, okay, let's This one is explaining a little more in detail. Connecting a network using private addresses to the internet requires translation of the private addresses to public addresses using NAT, that is network address translation. NAT here. And we learn about this NAT in detail later. Anyhow, here we are focusing on the private IP addresses. And that address range is standardized like this. Among A class, among B class, among C class, this one is reserved for the private IP addresses. Thus, you should remember, I recommend to remember, because we are using these IP addresses probably everywhere in the world. Also this one, the C class. Please try to remember this one. Okay, this one is explaining about the CIDR format. CIDR format we used briefly in the previous example, but let's focus on that CIDR format in more detail here. CIDR means class list. Our previous example about IP addresses based on class ABC. And this one is not using class, no class. Thus, this one is class list inter-domain routing. And with this notation, we can show the subnet path of address of arbitrary length. And address format, as we looked at briefly in the previous example, the slash and some number. That is the CIDR notation. This X is the number of bits in subnet portion of address, as we learned already, like 24, here 23. Then among these 32-bit, only 23. Until here, that is 24. But here, until here, only this one. That will be used for subnet address. In this way, we can show how many bits are being used for subnet path. Then, of course, the remaining among 32-bit minus 23 here, that will be used for host ID. 9 bits. Thus, how many hosts we can attach in this network? 2 to the power 9. And as we learned already, we should subtract 2 because all 0, all 1, that 2 cases should be eliminated. Thus, that is the (510). That is the whole number of host IDs in this subnet that can be used. Okay, let's move to the next. This one is explaining, okay, let's change it back. IP addresses, how to get one. Then to use in our house, think about how our house or in our company or in our university, to get one IP address. And that should be unique at first. If we are using private IP address, that doesn't need to be unique. How does a host get IP address? If we want to get worldwide unique IP address, then that should be given, and that will be explained. First, let's look at this one. Hard-coded by system administrator in a file, and we can look at that and we can assign that here depending upon our operating system, Windows or Unix machine. Or sometimes with our notebook, some Wi-Fi network, we don't need to assign any IP address if we are using this DHCP protocol, and we learn this protocol later in detail about this. This full name is Dynamic Host Computation Protocol. This is automatic. Automatically we can get IP address. Here we are assigning manually. We are putting our IP address to our internet capable device. This one is working as plug and play, DHCP. And to use this one, there should be some DHCP server. This server is providing that service. If there's no DHCP server, then we cannot use this one. Okay, let's move to the next. Okay, this one is explaining about the DHCP, Dynamic Host Computation Protocol. Goal is allow host to dynamically obtain its IP addresses from network server when it joins network. This server is doing that. This server is using this protocol, DHCP protocol. Can renew its release on address in use and allows reuse of addresses, only hold address while connected one, and if that is not disconnected or power off, then that same IP address may be assigned to other device, to other computer, or to other notebook. Support for mobile users who want to join network. Or shortly, in very fast time, we can connect to the internet using this scheme. And this one is explained about DHCP protocol. DHCP protocol is working in this way. First, think about your computer or notebook needs some IP address. Then your notebook is broadcasting DHCP discover message. And the DHCP server, if there is any DHCP server accessible in the network, then that is responding to DHCP offer. This one is offering. This is DHCP offer message, and your notebook or host computer requests IP addresses. DHCP request message. Among that offer, this offer may be offered by many DHCP servers, and our notebook is selecting one of them if there are many offered IP addresses, if there are many DHCP servers are there. Of course, if there is no DHCP server, then we cannot request because there is nothing. And the DHCP server finally sends address, DHCP acknowledge message. Because if there are many DHCP servers and they are providing and offering, then I am requesting only one of them. Then this one will be acknowledged by that DHCP server providing that IP address. Okay. Okay, this one is explaining about the DHCP client server scenario. As I mentioned, if we want to use DHCP functionality, then there should be DHCP server. And here, this is our notebook. Let's assume this is arriving DHCP client needs address in this network. If there is any DHCP server in this network and accessible, then this one is providing that information depending upon that DHCP protocol. This one is the interaction during that DHCP server interaction between this DHCP server and this DHCP client. Okay, first, this arriving client is requesting discover first, sending this DHCP discover message, as we learned. Broadcast, is there a DHCP server out there? And if there is any DHCP server, then this one is responding. And broadcasting way, I am a DHCP server here. Here is an IP address you can use. Then this one, the client is broadcasting, okay, I will take that IP address. If there is another DHCP server, as I mentioned, then this one will broadcast this one. Then this one should choose among them. And if this one is choosing one of them, that will be arrived to this one, this server. And the other, this one is neglecting that. And that IP address offered by this one is not assigned to this one. That may be used for other client later. And this one, not this one, this server is broadcasting, okay, you've got that IP address. In this way, our protocol is working, and this is client-server interaction for DHCP. Okay, DHCP can, okay, I'll use this pen. DHCP can return more than just allocated IP address on subnet, address of first hop router 1 client. Think about our internet configuration. We need IP address. What else? Subnet mask to identify that subnet. What else? DNS server information, and also what else? Gateway, IP address, this one is called first hop router. That is, in other words, gateway. Name and IP address of DNS server. If name is provided, then the IP address will be found. And network mask, subnet mask, this one, indicating network versus host portion of address, as we learned already, to identify the subnet part. Okay, this one is the example for that DHCP operation. Here, first, connecting laptop or notebook, this one. Needs its IP address. Then address of first hop router gateway IP address and address of DNS server. And we don't need to provide. And automatically, if there is any DHCP server providing that information, that will provide that information automatically using DHCP protocol. And here, our notebook, if we are considering the 5-layered stack, then this one is application layer. Next one is transport layer. And this one is network layer, which we are learning. Next one is data link layer. Final one is physical layer. And here DHCP protocol, that is application layer protocol, and that will be transferred in that way. Some header in this transporter layer, another head in this network layer, another head in this Ethernet or data link layer. That will be sent through that network to the DHCP server, if there is any DHCP server. Usually, router has that kind of functionality, and that is built in usually into the router. DHCP request encapsulated in UDP, and this one is using UDP instead of TCP. And here, UDP instead of TCP. For DHCP server, DHCP protocol, this one is not being used. And that will be used to encapsulate this one, arrow point Ethernet. And Ethernet frame broadcast destination on RAN, and that will be broadcasted because we don't know any specific IP address for that. That's simply broadcasted, and that will be arrived there because they are located in the same subnet, and the router is doing that functionality. Then router will receive that, and this router is learning that DHCP server functionality, and that will be arrived in reverse way here. Ethernet and UDP, and finally DHCP in the application layer. That will be arrived there. Then DHCP server formulate DHCP acknowledge. Okay, let's use this pen here. Containing client IP address. IP address is a first hop or gateway router for client, and DNS server information, and that will be send it back. And encapsulated of DHCP server and the frame ported to client, and that will be arrived there finally. Client now knows its IP address. Some detailed interaction is omitted, and now finally the client, this notebook, will get that information which we want. Name and IP address of DNS server, IP address of its gateway router, first hop router, in other words. And we can use internet if those are configured properly. Then this one is explaining about that IP address assignment, how to get that IP address in the world. How does network get subnet part of IP address? Answer is allocate portion of its provider's ISP's address space. Internet service provider is providing that. Then from whom that ISP is getting that IP address. That will be explained in next slide. This internet service provider will provide that IP address. This IP address range is managed by this internet service provider, and among them, one or two group of IP addresses will be assigned to our company or to our house. Instead, we are paying, depending upon that subscription of the internet as an internet subscriber. We are paying monthly payment. Here, ISP's block, IP address block here. And some portion or one IP address will be assigned to this organization. This may be company or university or house. And in this case, that is larger block, thus that is smaller number, and the last part is for host ID. But among host ID, okay, here that line is wrong. Here 20 means 16 and until here. Okay, I'll use other color pen. I'll use this one. Okay, 20 bit means here until here. 16 and 4 bit, that is 20 bit. There's this one means here. This one is used for subnet ID. Next part, that will be used for host ID. This one is subnet. And among them, this was originally this one was host ID. Among host ID fields, these 3 bits are being used for subnet. Here. Until here, that is being used for subnet. This one is called subnetting. Original block was big, and among that host ID, some portion that will be assigned to subnet part, like this. Then this one is reduced. Host ID part is reduced. Thus the number of hosts which we can assign, that will be reduced. That's the 9 bit. There's the 2 to the power 9 minus 2. That is whole number of the IP addresses. That means whole number of clients or whole number of devices we can hook up in this network. Each one, like that. This one is called subnetting, and we learn. In next slide, let's move to there. Before that, let's look at this hierarchical addressing. Root aggregation. This one is explaining about the aggregation. Hierarchical addressing allows the efficient advertisement of routing information. Let's think about the worldwide network, internet, and that should be notified to the world, advertised, because some datagram, if that datagram IP address, destination address is to this one, then that should be reached in easy way. Thus that should be notified, advertised here. Organization 0 and through 8, through 7, thus 8 organizations using fly-by-night internet service provider. Send me anything with the address is beginning. Instead of the wrong number, there's the aggregated group 20 instead of this 23, because those can be aggregated together. Then this one is representing group, only 20 bits in that block. Those are located. Thus this one is advertised. This one is called aggregation. Okay, let's move to next. And this one is explaining a little bit more about that, but the specific example, and one of them is, okay, let's change it back to use this pen. Moving to other area, then that should be advertised properly to get that destined datagram from the network, from the internet, then that should be advertised. Send me anything you to addresses. This one was the same to the previous one, and this one is moved to here, and this one is advertised. And neglect this one, because in Korea usually if we are changing internet service provider, this one is changing internet service provider, and that same internet service provider, even though that ISP is being changed, this company is using same IP address, but usually in Korea that cannot be used in that way. Thus you don't need to worry about this, just for reference, but neglect. Okay, this one is explaining the final words for this IP addressing scheme. IP addressing, the last word. How does an internet service provider get block of addresses? Think about your internet service provider. How that ISP is getting that IP address block. In Korea, ISP is provided by this KISA, Korea Internet and Security Association. This company, this government, semi-government organization is providing that IP addresses. Then, who is providing that IP address to this KISA in our country? In other countries, there may be the other organization, but who is providing worldwide? There's some regional area. Finally, there is one organization that is called ICANN, ICANN. The full name is Internet Corporation for Assigned Names and Numbers. Names means domain names. Even domain name will be assigned by this one, have been assigned by this organization. And the numbers, that is about IP addresses. Also autonomous system number, later we learn about that. This is domain name, system, domain name. And this one is allocating addresses and manages DNS and assigns domain names, and even some resolution of disputes. If there is some problem in terms of that property, IP address is a kind of property, and this one is trying to resolve that dispute. Okay, let's move to the next. Okay, this is a good point to wrap up here, and we'll continue this discussion later in next